Okay, so I think we started out, I for sure mentioned that I is the square root of -1, and I squared is -1. Do you remember what I cubed is?
I no, I don't.
So if you look back, it's I cubed is really I squared times I to the power of 1. And I squared is -1. So this was -1 here. So -1 times I is -I. And then I to the fourth, let me do that off to the right here. I to the fourth is really I squared times I squared. Okay.
Okay.
Which is -1 times -1, which is +1.
Okay.
All right. So here's the summary. And these are the four things you need to do. I'm going to just summarize them right here. I is the square root of -1. You know that. I squared is -1. I cubed is -I. And then I to the fourth is +1.
Okay. Got it.
So why would you need to know this? Well, because they could give you a problem like the following. They say, like, what is I to the sixth? Okay. And you may or may not see a pattern yet, but I to the fifth is actually the square root of -1. And I to the sixth is -1. So there's actually kind of a rotation here, but there's a better way to do it. So you actually take this 6 and you divide by 4. Okay. And you're like, why would I do that? Well, if you go back in time, you first learned that this is 1 with a remainder of 2. And that remainder of 2 is what indexes into this list. So the first one is a remainder of 1, remainder of 2, a remainder of 3. And the last one here is actually a remainder of 0. So you actually just need to know these first few.
Okay. Got it.
All right, so now this is really I to the sixth is really, it's really I squared, which is -1. Okay. And it's not too bad when it's like when it's a small list like this, but let's say it was I to the 66 power.
Right.
So for example, it'd be like 66 over 4. And if you were to do the long division, you would find that that is 16 with a remainder of 2. So it also ends up being I squared. All right.
Okay.
So now, a larger problem though, like what if it was like actually, let me grab this list here. Grab this and bring it down. So let's say it was like something like I to the 431 power.
Okay.
So you got to do the same thing. I was like, I have 431 divided by 4. Yeah, this is where if you don't have a calculator, maybe do some long division, but it's 1, the 4, you subtract, bring the 3 down, doesn't go into 3, bring the 1 down. It goes into 34 7 times. 7 times 4 is 28. And so it is a remainder of 3. And that's what you care about. That 3 tells you that, oh, it's actually really I cubed, which is -I.
Hmm.
Right. This is just one type of problem you might see.
Okay.
Let me give you one. Let me give you this list here. So let me have you try the following. I to the 520, please.
Okay. Is it just one?
It is 1. Good. Okay, good. Now, last time, so sorry, just to summarize, you should you should know this list from an algebra. Well, you haven't taken algebra 2 yet.
My school doesn't have algebra 2.
That's right. It goes to pre-calc. Like this will be covered again. I don't know. It's just one of those things where I'm throwing it in here. So let's look at some other ones here. Like let's say I have you do something like this. It's like 3i times 4i minus 5 plus 2i times 3i minus 6. And I just ask you to simplify. I think we looked at a couple of problems like this last time. This will just be review. The thing here is you have to distribute into both. So it becomes 12i squared minus 15i plus 2i squared minus 12i. That's where you have to remember that I squared is -1. You have to be able to reduce these. So it becomes minus 12 minus 15i minus 2 minus 12i. And then you combine like terms. So it's like minus 12 minus 2, that's minus 14 minus 27i.
Okay.
Any questions on this? Because I like to give you one to try before we move to division. That's the harder one.
No questions.
Okay, so let me have you try one here. Minus 3i times 4i plus 1 plus 6i times 3 minus 2i.
Okay. Is it 15i plus 24?
I know there's a mistake there. No, I'm sorry. I didn't mean that. I did no. I take that back. That might be correct here. Let me just work it out here. Sorry, I was looking at something else. Minus 12i squared minus 3i plus 18i minus 6i squared. This becomes positive 12 minus 3i plus 18i minus plus 6. So what I see here is something different. What do you have? What does yours look different than this? Because I'm guessing there's a difference between this first line to the second line.
Yeah, I had a in the second line I had 12 -12i squared minus 3i plus 18i minus 12i squared.
Oh, I made the mistake. I'm sorry. Yeah, that's awful. I've been making mistakes all day. I've been something wrong with me. Yeah, this is correct. Good. Okay, Matthew wrong, Gracie correct. I like it. You know, I've heard a few students lately tell me, you know, hey, what should I do if, you know, ask me what should I do if my teacher makes a mistake or I notice a mistake. You just, as kindly as you can, ask them, say, hey, you know, I've got something different. You know, and see if you can find it, or don't be afraid to ask, because I absolutely make mistakes, and I'm glad you caught that one. So we're gonna look at something new here. We're gonna look at 3 minus 4i times 5 plus 3i, and we're going to foil this. Okay. All right, so we have 3 times 5, 15. 3 times 3i, that's 9i. Minus 4i times 5 minus 20i. Minus 4i times 3i minus 12i squared. Okay. So that's 15 plus 9i minus 20i. And then I squared is -1. Sometimes it's good to really show it, even if you just to double check that you get the right right thing there in terms of your sign. So final answer here is 27 minus 11i, like that.
Okay.
And there's a reason we're foiling here. So if you don't mind, if you could just do one on your own here, and then we'll jump into division. There's a reason for that. So let's have you try this. 2 minus 3i times 5 plus 6i. You could try this one on your own, please, and let me know what you come up with.
Okay. Is it minus 3i plus 28?
Yes, but I'm going to write it differently, because the answers are supposed to be in this form, a plus bi. So basically the number first, then the number with the I.
Okay, right.
And it's like a small thing, right? It's like, well, why does that matter? I don't know. I mean, there's probably a lot of examples I could give, some meaningful, some not, but this is the preference. It's like, it's got to be in this order. So you just do it that way. Okay. So this is all leading up to a problem like this, something that says to simplify the following, something like 1 plus, well, 4 plus 2i over 3 minus 5i. Something like this. Have you seen something like this before?
Yes.
Okay, so there's this thing, and they call it the conjugate, and we just need to briefly talk about that. Okay, and the best way I think to do it is to go through all the cases. Okay, so the conjugate works both directions, meaning that the one on the left and the right are conjugates of each other. You only change the operator. Okay, 3 plus 5i. So whatever the operator is in the middle, that's what changes. So let's say it's -3 minus 5i. Well, it becomes -3 plus 5i. You just change the operator. Okay. So
Okay.
just the thing in the middle. So let me give you another. Let's say it's 4 plus 6i. What would the conjugate be?
Just 4 minus 6.
Yes. Let's say it was a -7 minus I. What would the conjugate be?
7 plus I.
You only change the operator.
Oh. Okay.
-7 plus I. So the only thing that changes, and I'll just highlight that, is like this goes to a plus, the minus goes to a plus, plus goes to a minus, minus goes to a plus. Okay.
Okay.
All right. So you have to know that. And this also applies to roots, but we're gonna deal with that in a moment. What is the conjugate? Well, it's already written there. That's a silly question to ask. So you multiply the top and bottom by 3 plus 5i.
Okay.
So the reason I asked you to FOIL those previous ones is because guess how many FOILs you have to do here? You have to do one for the top and the bottom. Okay. So we're gonna do the bottom first. We're gonna do that down below here. So it's 9 plus 15i minus 15i minus 25i squared.
Okay.
That's foiling the bottom. Now, let's keep going here. Let's simplify that a little bit. The last one is minus 25 times minus 1, which becomes positive 25. What happens to the outer and the inner term?
They cancel.
They cancel. So it is always the case, it is always, always, always the case that when you multiply by the conjugate, you get a number. So the bottom becomes 34. This
Okay.
becomes 34. That is always the case. The top, though, does not become a number because it's not the conjugate times itself. So let's look at the top here. Will you FOIL this for me, please?
Yes. Um. 12 plus 26i minus 10.
What's your final answer? Give me your final answer when you FOIL that.
Oh, 2 plus 26i.
Yes. Okay. And as a reminder, it was 34 on the bottom. Okay. So now this is not done though. It's close. You're supposed to divide each of these. Now I was working with a calculus student last night. He forgot that it's both. You don't get to choose. So it's just something you gotta remind yourself. And they both can be reduced. You can reduce both of them by 2. So it becomes 1 over 17 plus 13 over 17i.
Okay.
Okay, so the key here, if we go back to look at the beginning of the problem, the key is to recognize, okay, I got to multiply by the conjugate. The conjugate is just a change in the operator. You FOIL the bottom, you should always get a number on the bottom. You FOIL the top, you should always get a number on the top. Let's give you a pretty basic one to start out here. Let's go 2 plus 3i over 1 minus I. Can you tell me what the conjugate is of the bottom, please?
Okay. Wait, 1 plus I.
Yes. And you multiply the top and bottom by that. Okay. So for now, could you FOIL just the bottom and tell me what you come up with when you FOIL that?
Yes. Is it 2?
It is 2, yes. Okay, so do the same thing for the top and let me know what you come up with.
Okay. -1 plus 5i.
You got it? So this one's a little different. It's not both divisible by 2, but most teachers, most textbooks really want you to rewrite it as -1/2 plus 5/2 I, like that.
Okay.
All right, so we've really done a lot of complex stuff. The only other types of problems I can think of, I believe we did some last time, were quadratic formula, but then also the ones where it's like, hey, how do you solve something like this? How do you solve x squared equals -16? Do you remember from last week what to do for a problem like this?
Is that when you do the square root of both?
Both sides, yep. So it's plus or minus the square root of -16. On the right, though, this is the problem. This is the issue, because you cannot take the square root of a negative number.
Right.
So what do you do? Like, it's like, what do we do from here? It's like, well, you give up. No. You can break it apart. It's the square root of -1 times 16. And then it's the square root of -1 times the square root of 16. You break it up, and hopefully this becomes more familiar, because we talked about earlier, what is the square root of -1?
I.
And square root of 16?
4.
4. Now, as a preference, you put the number before the I.
Okay.
So let's have you try one.
Okay.
Make it a little different here. Let's say it's x squared plus 25 equals 0. And it says to solve. Any questions for me? Do you have a final answer?
5i.
Is that your only answer?
Or -5i.
Yeah, they're both correct. I used to put up a question, I think I still have it, where the first answer was like 5i, and then like D was plus or minus 5i. And it's one of the strategies we'll talk about in the class, but sometimes you got to remember, like, why is there 2 there? Because there's 2 solutions. That tells you there's 2 solutions. So excellent. Okay, now what if I asked you to do something like this? X squared equals -80, and take the square root of both sides plus or minus the square root of -80. So we know it's I square root 80. Do you remember how to reduce a root like this? This is not a perfect square. It's not like 25, 36, 49, 64, 81.
No, I don't remember.
Okay, so we'll look at that here a bit. So you start, there's 2 choices. There's either a factor tree or there's a factor ladder. They're basically the same, but does one of those stand out to you?
Factor tree.
Tree. Okay, so you start with the lowest prime number, which is 2, 3, 5, 7. Probably don't have to get much larger than this, but it's good to know your prime numbers. Now, does 2 go into 80?
Yes.
And it's 2 times 40 gets you back to 80. And then you
Yeah.
try 2 again. You're like, all right, well, it worked. Let me try again. 2 and 20. Great. And you try it again. And you just keep trying it until it doesn't work anymore. All right. Now, you're done because it's a prime number on the leaf here. These are also prime numbers, but that's how you know when you're done.
Okay.
And what you do next is you circle pairs. They have to be matching pairs. I'm not sure. I like matching socks. Some people are more into the mismatched socks. These have to match. You have to get a matched pair.
Okay.
And for every number you have a pair, you bring it out. So you bring out a 2 and out a 2, but you leave in a 5. And this is just the root part. So outside, there's a 2 on the outside, a 2 on the outside, square root of 5 on the inside.
Okay.
And this plus or minus I stuff still comes down like that. So it's 4i plus or minus 4i root 5 like that.
Okay.
You probably reduced roots when you were doing the Pythagorean theorem at some point. So hopefully this doesn't look too unfamiliar.
Yeah.
Let's have you try another one though. Can you do the square root of 120? Can you try breaking that apart for me, please? Just the square root. Don't worry about the plus or minus and all that we were doing.
Okay. So is it is it
You're probably right. Just you got to trust yourself. You have a little more confidence.
4 times 30 or 4 times square root of 30?
Okay, that looks pretty good. So 2 and 60, 2 and 30, 2 and 15, 3 and 5. So what you have is really, really, really close. Okay, really close. All right. So there's a pair of 2s. So a 2 comes out. Are there any more pairs on the leaves?
No.
No. So I was just gauging where you're at because you've got really good math skills, and I wanted to just kind of throw one at you a little harder than I would normally give just to see. But the 30 is correct because the 2, the 3, and the 5 they go in.
Okay.
All right. So the 30 is correct, but it would be 2 out square root of 2 times 3 times 5, which is like you said, it's the square root of 30.
Okay.
So let me give you a more basic one here to try out. Let's say it's square root of 24. Would you try that one for me, please?
Yes. Is it 4 times the square root of 6 or 2?
There is, yeah, there's this is not quite right. So do you want, so let me work it out here with you. So it's 2 and 12. Did you get that?
Yes.
2 and 6, 2 and 3. And it's such, you got to circle the pairs. You can't just look at them. You got to really circle them. So a 2 comes out. Do you see that?
Right.
And what's left over? What is still inside here?
2 and 3.
2 times 3. So it's 2 square root 6.
Okay.
Let's try another one. Let's try another one. This is an important skill. It's a worthwhile for our time here. Let's try the square root of 45. Okay. Now, most of them have worked with 2, but this one does not. Now I know it's tempting to go to 5, but you really want to do them in ascending order. You really want to try 3. 3 does go into 45. The divisibility rule for 3 is you add up the digits, and if the sum of the digits is a multiple of 3, you're in good shape.
Right. Okay.
So this one you have to try 3. So give this one a try, please, and let me know what you come up with.
Right. Um, 3 times the square root of 5.
Good. Yeah. 3 squared 5. Good. Okay. All right. Let's do another one here. Let's do the square root of 200. Let's have you try that one.
This one, if there's a pair of 2s and a pair of 5s.
They both come out.
Okay. So 10 times the square root of 2.
Yes. Perfect. Really good. Really good. Good. Okay. So all of that was being done because we're solving problems of this type, like x squared equals minus 80 or x squared plus 24 equals 0. All of these types of problems you end up having to reduce a root. Okay. And I think you've got that down. So we can move on to a new topic, if that's okay with you.
Okay.
So I thought we could do some of these either factoring, I guess factoring or rationals. So a rational would be something like x over y plus 1 over x. Like these are rationals that you have to add, for example. Or we can talk about all the different types of factoring that there are. And there's a bunch. There's the GCF, there's the difference of squares, there's perfect square trinomials, a equals 1, a not equal to 1, grouping, etc. Which direction would you like us to go in?
The
And you should choose the one you think you're less confident in.
the first one.
The rationals.
Yes, please.
Okay. All right. So let's build up to that problem here. Let's say I asked you to take 4 over x plus x over 3, and I wanted you to add these. You have to make a like or a common denominator.
Right.
Can you tell me what that common denominator would be?
3x.
3x. So sometimes it's as simple as multiplying them together.
Right.
Okay, sometimes. Okay, and that's the first case. So it's 12 over 3x plus x squared over 3x, and the numerator becomes 12 plus x squared over 3x, something like that. So that's kind of the like what I'm seeing most of your problems being like. But let's do something kind of related to this. Let's say I asked you, what is 1 over 1 minus a over b? And it would say to like simplify something like this. Now, really, you're just looking at the bottom. You're like, okay, like there's a number on top. The bottom is a fraction. I got to deal with the bottom.
Right.
So how do you write 1 as a fraction?
1/1.
Yes. Now, what is the common denominator here?
B.
B, yeah. So you multiply both of these by B, and you get B minus A over B. And all of this here is replaced. We're going to replace that in the fraction there. So it becomes 1 over B minus A over B, like this.
Okay.
Now, do you remember how to deal with a fraction within a fraction?
You multiply
So you
by
take 1 and you multiply by the
a denominator.
you take the reciprocal of this, or the flip. So it's B over B minus A, like this.
Okay.
I feel like you haven't seen that before. Maybe just because it's all letters, you didn't like that.
Yeah.
Okay. So the ones don't do anything, so you end up just getting B over B minus A. So before I give you one more like this, let me give you a numerical one here to try. So let's say it's gonna have variables in it, but 4 over x over 16 over x squared. Okay, can you reduce this or simplify, please?
Yes. Would it become 4 over x times x squared over 16?
Yes, you multiply by the reciprocal.
Okay. And then 4x squared over 16x.
Yes, but there's more to do. You can't leave it like this and expect full credit. You have to be able to reduce this.
X over 4.
Yes. Good. Okay, so as promised, let's do one of these complex fractions. Let's look at 1 over 1 minus x over 2. Okay, so you really just want to focus on the bottom here. You want to make a common denominator on the bottom here, combine the top, keep the bottom, and then it's very much like this one up here, but with some numbers in it. So give this a try. Let's see
Okay.
what you come up with. If you have questions, of course, please ask.
Okay. Is it 2 over 2 minus x?
Is this like this your final answer?
Yes.
Okay, so it becomes 1 over 2 minus x over 2. And then you do just flip it 2 over 2 minus x. Very good. Perfect. Okay. So, why are we doing this? Well, you might get a problem like this, something like x, y over x minus 1 over y, something kind of absurd like this. It's the same process. You still want to make a Actually, let me put a 1 over this up here. Let me yeah, let's do it this way. You still want to make a common denominator. Okay. So you really look at the bottom here. The bottom is your common denominator is going to be the xy. So you multiply both of these by y. Xy minus 1 over xy. And then, like you said, you multiply by the reciprocal. Now you don't have to multiply. You can actually cancel in this form. You can cancel these because they're really in the top. The xy is in the top. This is in the bottom. Even though they're kind of diagonal, the multiplication, they're really squeezed together, and 1 is left in the top there like that.
Okay.
All right. Now we haven't done a numerical one in a while. So let's do that, or more of a numbers one. Let's say it's something like 2x plus 1 over 3 minus 4x plus 5 over 2. And again, it just asks you to simplify. This is not anywhere near as sophisticated as the ones we were doing, but any idea how to proceed from here?
A common denominator.
And what is the common denominator here?
6.
6. So that means you're going to multiply everything on the left by 2 and by 2, and everything on the right by 3 and by 3. All right. Now, how do you handle this, the subtraction operator? How does that apply?
You can make it plus the reciprocal.
No, we're not. So no, not. That works for multiplication. Sorry about that. So what I'm referring to here, and actually let me show this out. So it's 2 times 2 plus 2x plus 1 minus 3 times 4x plus 5 all over 6 like that.
Oh.
And so what I'm asking is, or I'm trying to get you to say, is that minus 3 is what distributes to both.
Right.
So could you give that a try, please? Distribute or work this out from here.
Is it minus 8x minus 13 over 6?
Yes. Very good. Okay, so the last type of problem that I'm seeing that they're giving you on this rationals is something like this, like 4 over x squared plus 3x minus, let me put a 4x there, minus 2 over x, like this, 2 over x. Okay, and so the reason I said this is the last style is because you have to factor on the left here. So look at that. We still did some factoring. Can you tell me how to factor x squared plus 3x?
It would be x and then
So this is a GCF, greatest common factor.
okay.
4x over x times x plus 3. Okay, now what is the common denominator here based on what you're seeing?
x times x plus 3.
That's right. And the one on the right is missing an x plus 3.
Right.
So this is 4x over x times x plus 3 minus 2 times x plus 3 over x times x plus 3. Could you work this out from here, simplifying the top?
Mm-hmm. Can you cancel out the x plus 3 on the right side?
You can, but then you're going backwards. Remember, our whole goal was to get a common denominator.
Right.
So if you cancel them out, you end up off to the right here. You end up back at the previous line.
Right.
And you don't want to do that. I sometimes say it's like making 4 right turns. You go right, you go right, you go right, and you go right. You're back where you started.
Right. Okay. Is it 2x minus 6 over x squared plus 3x?
Sure, you can certainly distribute the bottom if you need to. That is absolutely okay. You can also leave it in factored form like this. This one might also be factored like this, where you take a 2 out of the top. So just be on the lookout for that. Okay, so I'm going to stop the recording